All right, so this is the first week of the engineering economics course, and we are going to start with our first chapter, where we are going to give a little introduction about the engineering economics, and we are going to mention about the basic concepts. So we are first talking about the main principles of engineering economy and the analysis procedure, the steps that are being followed in engineering economic analysis. And then we are going to talk about a few basic concepts which we are going to mention so many times throughout this course. Okay, so we are going to talk about the concept of interest. Actually, you know what interest is already. And then we are going to talk about the equivalence, the future word and the present word of monetary units. And we are going to provide you a few examples related to cash flows and the cash flow diagrams. Then we are going to finalize the first week's topics. So actually, the main idea of this course, the main idea of engineering economics, resides on the base of the time value of the money. So we need to understand the time value of the money in the beginning, so we can understand what engineering economics and the analysis to this field are dealing with. So I'm going to ask you a very, very small question. Let's just say I'm going to give you 100 Turkish liras. Okay. There are two options here. Either I give you this 100 Turkish liras right now, or I can give you this 100 Turkish liras 1 year from now. Okay. Either you take the money right now, 100 Turkish liras, or 1 year from now, I will give you the same amount of money. Which option would you choose? I mean, this is not a very hard question, and any clever thinking should choose to take the money right now, right? So nobody waits 1 year from now, and the cleverest answer is to take the money right now. And why do you do that? Because if you take the 100 Turkish liras right now, you can simply invest that money into a savings account where you can gain interest without any risk. And 1 year from now, you are going to have 100 Turkish liras plus the interest that you gain from that savings account. Therefore, the second option will remain as a worse option compared to the first one. Okay, so if you choose to take the money right now, you are going to have 100 Turkish liras plus the interest 1 year from now. But if you choose to take the money 1 year from now, you are just going to have 100 Turkish liras. So you see the same amount of money at different time points now and 1 year from now, they do not have the same value. Okay, the value of the money changes through the time. Okay, so the first sentence in this presentation file, the principle that $1 today is more valuable than $1 a year in the future, this concept is called the time value of money. Okay, anything sooner, any amount of money that is sooner is more valuable. Why? Because you can gain interest from that money in the following year. Okay, money has an earning power. The more money that you have, the more possibilities that you gain even more money. Okay, so having money sooner allows more interest or income to be earned. The only option that you can choose is not the savings account. Of course, you can take 100 Turkish liras right now and you can invest that money into a business. Okay, so but that investment would be a risky investment. Okay, the savings account will definitely give you some interest, that is definite, but if you invest that money into a project or a business, then even if the expectation to make profit is high, there are some risks associated with that business or project. Okay? Now, if you do not invest your money anywhere, if it remains uninvested, as it is mentioned here, the value of money will be lost. So if you take 100 Turkish liras right now, and if you put that money under your pillow, okay, keep it there for 1 year, then even if you take that money 1 year from now, even if the number on that cash is written as 100, okay, the value of that money is going to be lost, because 1 year from now, with 100 Turkish liras, you will not be able to purchase the things that you will be able to purchase right now. Why? Because of the inflation, right? So the inflation, if we have an inflationary economy, and usually we have, okay, so if you have an inflationary economy, you will not be able to purchase the same things that you will be able to purchase with 100 Turkish liras right now if you wait 1 year. But if you invest that money into a savings account, then the money is going to gain interest. Then you will have some chance to purchase the same things that you can purchase right now. Okay, but some chance. Usually the inflation rates are higher than the interest rates. Okay, so we'll see about it. Okay, we'll see, and we are going to learn about the inflation rates and the interest rates. And also there are exchange rates as well. I mean, the value of the money is not just dependent on the inflation rates and the country's economy. The exchange rates are also important, because the most of the things that you purchase through import, right? So we purchase these products, many products, from abroad countries. Therefore, the currency exchange rates are also effective on the time of the money. Okay. For example, if you keep 100 Turkish liras right now, and if you do not invest into a savings account, the money's value is going to be lost, not just due to the interest rate that you have missed to take. Also, if the value of the dollar or value of the euro increases against the Turkish liras, again, your money is going to lose its value. Okay, so we are going to start with the simple question to understand the time value of the money better. So we say Joe Minor has been offered a student loan by a hometown engineering firm. He will borrow $5,000 each year for 4 years. He is required to graduate within 5 years. After a year from the graduation, for the following 4 years, he is required to repay his loan at $5,000 per year. Is this a good deal? The question asks. Now, the answer is simple. Yes, of course, this is a good deal because of the time value of the money. Okay. Now, the time value of money says that the payments are worth less than what was borrowed. So if you purchase $5,000 right now, okay, and then you are going to pay your first installment 4 years from now, okay, you get $5,000 right now, and your first payment of $5,000 is going to be paid in 4 years from now. So $5,000 today is much more valuable than the $5,000 4 years from now. Okay. So you can do with $5,000 many things. If you purchase this, if you borrow this $5,000 right now, you can invest this money into your studies. And when you graduate, of course, okay, as a student, when you graduate, you are going to be employed by a job. And if you invest on yourselves more, okay, if you invest on your education more, then the possibility that you are going to get a high salary job in the future is going to be more as well. Okay. But even if you do not find a job, and if you do not invest that money into your education, you can just put that $5,000 that you borrow now into a savings account, which offers you interest. In the future, you are just going to pay $5,000 in any way, and all of the interest that you are going to earn from that savings account will be yours. Okay, because of that reason, this deal is a good deal. Okay, so let's understand the engineering economy now. We understood the time value of money, and let's understand the engineering economy. Engineering economy, or engineering economics, evaluates the monetary consequences of the products, projects, and processes that engineers design. Okay, so when we invest in a project, so let's just say you have enough cash and you want to make more cash out of it. You want to create a business where you can get profits. Okay, so this means you are going to invest in a project, or maybe you are going to manufacture a product and offer this product to the society in the market. Okay, or you are going to create a new process, a service process. As you can see, if we want to create a business, we invest our money into products, projects, or processes. Okay, and all of these products, projects, and processes are designed by engineers. Okay, processes are designed by industrial engineers. Products are designed by mechanical engineers or other type of engineers, engineers related to that product. And projects, okay, projects are collaborative works of engineers. So when we design such products, projects, or processes, they require some initial investment, and also they create some costs in the future that is to be paid. But eventually they are going to create some profit as well. So right now and in the future, there will be some costs and the profits related to these products, projects, and processes. And if we have alternative products to choose among these, or projects or processes, usually we compare these products, projects, and processes with respect to their current and future cash flows. Okay, so we need to compare these designs with respect to their cash flows, and we always choose the most economical one, which is the cheaper, okay, which is much more profitable in the long run. Okay, so engineering economy therefore uses mathematical formulas to account for the time value of money and to balance current and future revenues and costs. So what we are going to do is basically this: we are going to compare alternative designs of projects or products or processes with respect to their current and future cash flows, and we are going to consider the time value of the money in our analysis. Okay, so the real world of engineering economy includes also uncertainty as well. I mean, when you invest in a product, for example, you do not exactly know how much profit that you are going to make out of that product when you sell it, because you do not know the demand that you are going to have in the market in the future. Okay, so therefore there is an uncertainty related to demand. Therefore, there's an uncertainty related to the revenue that you are going to get. We say that all investments, they expose you to an uncertainty, they expose you to a risk, except the savings accounts. Okay, if you invest into a savings account, you gain interest, so that is determined. However, other type of investments, they always introduce some uncertainty as well. Okay, and there are some performance trade-offs whose value cannot be measured in dollars. Sometimes manufacturing products or investing in projects, they do not just create profit, sometimes they increase your reputation as well. This reputation may not be measured in dollars. Therefore, we need to consider these facts in our analysis as well. Okay, so what are the principles of engineering economy? So we have these following principles. The engineering economy methods are founded on the following principles. First, we need to develop the alternatives. Okay, and in order to develop these alternatives, we need to carefully define the problem. Okay, so every analysis method starts with defining the problem. So the problem is actually is very easy to define. We have some cash and we want to make some profit out of it, and which project or which investment we should choose. Okay, so there are such easy problems in engineering economics. However, if you have a business which is already going on, sometimes you need to make necessary decisions. For example, you are going to purchase a new printer. Okay, which brand of printer would you purchase? Okay, that is going to be the decision, and the alternatives are the brands. Okay, which brand of printer you are going to purchase? Okay, so you need to define the problem before starting the comparison. Okay, and you need to give a list of the alternatives. And your solution is going to be a choice or multiple choices among these alternatives. Okay, maybe you are going to choose one alternative, or maybe you are going to choose a subset of these alternatives. Okay, so we need to define the alternatives clearly. Then we are going to focus on the differences. Okay, how we can compare the alternatives. The differences in expected future outcomes among the alternatives are relevant to their comparison and should be considered in the decision. Okay, so if you want to purchase printers, if you have the alternatives as different brands, first their initial costs are going to be different from each other, right? So not every printer has the same cost. And also their future outcomes are also going to be different. Their future costs are also going to be different. And the profit or the profit that you are going to get from these printers are also going to be different. Okay. So the future outcomes of each alternative they are going to be different in expectation. Okay, in average, they are going to be different. Therefore, we need to compare these alternatives with respect to their differences. Okay. Now, the third principle is to use always a consistent viewpoint. So what does that mean? When we are evaluating the prospective outcomes in the future, they need to be developed from a defined viewpoint. Okay. For example, if you invest money into a savings account, from your viewpoint, you are going to lose some money right now, and you are going to get it back with the interest in the future, right? So from your viewpoint, right now there is a negative cash flow where you lose money because you are keeping it into the savings account, which means you are losing it. But 1 year from now, you are going to get as a positive cash flow. You are going to get that money plus the interest. Okay, this is your viewpoint. But if you look from the viewpoint of the bank, so which bank offers you savings account, that bank is going to gain some money right now. Okay, so from their viewpoint, there will be a positive cash flow. Then they are going to pay that money to you 1 year from now with the interest, initial amount with the and plus the interest. They are going to give you that money, which means 1 year from now they are going to experience a negative cash flow. So you see the same action here, where you invest your money into a savings account, is understood differently from different viewpoints. Okay, so from your viewpoint, there is a positive cash flow, a negative cash flow right now, and a positive cash flow in the future. But from bank's viewpoint, there's a positive cash flow right now and a negative cash flow in the future. Therefore, if we are going to study that action in engineering economics, we always need to use a consistent viewpoint. Okay, I'm going to emphasize this in the future examples many times. Okay. We always need to look through one perspective, always. And we need to use a common unit of measure. So we use a common unit of measure to enumerate as many of the prospective outcomes as possible. And that is going to make alternatives commensurable and simplify the analysis of alternatives. And we need to consider all relevant criteria in our problems. So selection of a preferred alternative may require to use several criteria. Consider both the outcomes enumerated in the monetary unit and those expressed in some other unit of measurement, or made explicit in a descriptive manner, it says. So remember now, when you're comparing alternatives in any problem, okay, for example, you are just going to select a supplier to purchase your products from, or you are going to open a new supermarket and you need to choose a location for that. Okay, in all of these decision-making problems, you have multiple criteria to consider. So when you are locating your facility, you need to consider it to be closer to the customer, but you also need to consider it to be closer to the suppliers as well. Okay, so you have two different criteria at least. Or when you are choosing a new supplier to purchase your products from, you are going to choose the supplier who is going to offer you the least expensive product. But money is not the only issue here. You are also going to choose a supplier who offers a high quality products. Okay, so therefore you see we have at least two criteria to consider here. I mean, if you think carefully, you are going to see that there will be much more criteria that you need to consider in comparison of alternatives. Okay, when you are comparing alternative supplier candidates, or when you are comparing alternative facility locations, you need to compare them under different criteria. And with respect to one criterion, one choice is better. With respect to another criterion, another choice is going to be better. So therefore, choosing among alternatives is not an easy problem due to the multiple criteria. But in engineering economics, we convert all criteria into monetary criterion. So we are going to choose the best alternative. We are going to convert every outcome, every prospective outcome into a monetary unit. Then we are going to make this comparison with respect to economical analysis. And also we need to make risk and uncertainty explicit. So risk and uncertainty are inherent. They exist in estimating the future outcomes of alternatives. Okay, with any alternative, for example, if you think about the facility location problem, at every location alternative, there will be some uncertainty or risk related to that. So if you choose to locate your supermarket in any location, you need to prospect the demand related to that location selection, but that is uncertain. So how many customers are going to visit your supermarket? It is uncertain. Therefore, in this decision, at every alternative, we also have some risk associated with alternative, and this uncertainty and risk should be recognized in our analysis and comparison. At least we need to find the expected value of the demand or the expected number of customers who are going to visit our supermarket when we locate it in a certain location. We need to find these expectations or statistical averages or forecasts. Then we are going to revisit our decisions. Okay, improve decision-making results from an adaptive process where the initial projected outcomes of the selected alternative should be subsequently compared with actual results achieved. So what does that mean? When you come up with a decision in engineering economics, you do not just say that that is the best decision and we are going with that. You choose that decision alternative or choice. However, you need to consecutively compare that choice with other choices as well. Okay, so anytime you can revisit your decision, and at any time you can go with another choice. Therefore, we need to revisit our decisions. We continuously need to compare our choices in performance with the other alternatives. So in engineering economics, there is a 7 steps analysis procedure, which is enlisted in your textbook as well. And these steps are as follows. We start with the problem recognition. So we need to define our problem clearly. And you will see that in our future examples and case studies, every problem starts with a very, very well definition. Okay, so when we are going to solve the problem, first we need to define it very carefully. We need to recognize the problem, we need to define it carefully, and we need to evaluate that problem from the system's perspective. So we need to consider a system, we need to assume a consistent viewpoint in that system, and we need to evaluate the outcomes of the choices. Secondly, we need to develop the feasible alternatives. Okay, so you have a problem and anybody can offer a different solution to that problem. So each solution, each different solution method or each different solution alternative is going to be your alternative. And how can we develop these feasible solution alternatives? By either brainstorming in a group environment, or the nominal group technique can be another alternative. Okay, so usually we use qualitative group techniques in developing the alternatives, and we are going to in the third step we are going to develop outcomes and cash flows for each alternative. So if we are going to compare these alternatives, then we are going to evaluate the possible outcomes under each alternative and the possible revenues or costs that we are going to experience in the future if we choose that solution alternative, corresponding solution alternative. Okay, so what is cash flow? At this point, we need to define the concept of cash flow. The cash flow is a money transfer from one organization or individual to another. Okay, it's a transaction. Cash flow is a transaction. For example, when you purchase a house from somebody and you take a loan from the bank, credit from the bank to pay that house, then you are going to pay some money on a monthly basis to the bank, right? So this is a cash flow. This cash flow is from you to the bank. Okay, but initially the bank gives you tons of money to purchase that house. So this investment starts with a cash flow from the bank to you. Then that flow turns into a reverse direction when you want to pay your loan on a monthly basis. There are also non-monetary outcomes as well in every investment, in every alternative. What are these non-monetary outcomes? When you go with a certain product, for example, as a choice, the customer satisfaction, when you sell this product to the customer satisfaction is a non-monetary outcome which cannot be easily measured with monetary units. Or employee satisfaction, employee or public safety, flexibility, environmental requirements, responsiveness, etc. There are some qualitative effectiveness metrics, okay, which are listed here. These are called non-monetary outcomes, and of course, when we are comparing alternative solution methods in our problem, we are not just going to look at their revenues or costs that is going to be created in the future. There will be some non-monetary outcomes as well here. But all of these non-monetary outcomes should be converted into monetary units necessarily in our applications. Now, in the fourth step, we need to select a criterion or multiple criteria, but in engineering economics, there exists usually a single economic decision criterion. We always intend to maximize our long-term interest or long-term profit. Okay, so when we are going to compare alternative solution methods to a problem, we are going to compare them with respect to the economical basis. Okay. And finally, in the fifth step, we analyze alternatives and compare the alternatives using the engineering economics principles, which we are going to learn through this course. We then select the preferred alternative after our analysis. And finally, the last step here, the seventh step, is the performance monitoring, and we post-evaluate the results. Okay. So we are going to focus on the fifth step here, the analysis and comparison of the alternatives based on the engineering economics techniques. And through this course, we are going to learn these techniques. This is going to be a quantitative course. We are going to learn too many quantitative concepts related to engineering economics, and we are going to see many case studies to solve our problems. So that is just going to be the completion of the introduction to engineering economics, and we can start the basic concepts with the next video. So at this point, I'm just going to stop recording.